Okay, so here we go. This is a diagram. And remember, in these diagrams where you are always observing two half cells like this, and this you are observing, this is one half cell and there is another half cell. In these diagrams, or these setups are for the reactions in which that, reactions taking place spontaneously, and as a result, the electricity is generated. And the voltage that is between these two half cells would be calculated. So this A is always a voltmeter. Okay. So in every diagram like this, there is a voltmeter. When we talk about B is salt bridge. And if sometimes examiner asks you what is salt bridge, so there are two purposes of the salt bridge. One is to complete the circuit, and the second one is to maintain the ionic balance on both the sides. To maintain the ionic balance on both the sides, we need salt bridge. Now see, if you see on the right hand side, we have a copper electrode and we have a copper sulfate. On the left hand side, we have a platinum black, which is an inert electrode, but we are inducing, or we are, introducing a hydrogen gas. So what would be C contain? C must be an electrolyte. So C must be a hydrogen ions, or beside hydrogen ion, you can either write HCl aqueous as well. Okay, because in either case, there is a hydrogen ion, and the concentration for these hydrogen ion, the electrolyte must be 1 mole per dm cube, as this is the standard conditions that are needed. Is this part is clear to everyone? Yes. If anyone have any doubt, kindly ask. Now, see over here. A student wishes to measure the standard electrode potential of Fe3 positive, Fe2 positive electrode. In the space below, draw and label the setup for the right-hand beaker that would be replaced when shown in the diagram above. So they are saying instead of this, we have to show the iron 2 positive, iron 3 positive electrode, the half cell. So in this case, remember, see, there are both the ions. And what would be the state of ion? Yes, aqueous. So in each case, when we have both the species are ions, then the electrode taken must be a platinum. Okay. Do remember whether if a electrolyte have a non-metal, or if an electrolyte have a only ions, then in those case, the electrode would always be platinum. And the solution have Fe3 positive ions of 1 mole per dm cube concentration. In the same way, this solution have Fe2 positive ions in 1 mole per dm cube solution. And it is going to be connected to the whole, this setup which is on the left of the above diagram. Is this clear? Yes. Yes, the online students, is this clear to everyone? If anybody have any doubt, kindly ask. Yes, Sanvint, Iza, Alishba, Hamna.
Clear, sir.
Okay. Now, what they are saying, predict how E of the Fe3 positive, Fe2 positive electrode would vary as the concentration of Fe3 positive ion is increased and the concentration of Fe3 positive ion is increased and the Fe2 positive ion is increased. Okay, so for that you need a data booklet first. So let's have a look. When you are provided with the conditions, here there is no condition is provided. That formula, that expression can be used only when you have the whole data. See, this is the equation. They said that the concentration is increased, but increased to what? You don't know. So how could you put the value over there in the next? So this is the equation. This is the half equation. This is the half reaction that is taking place over here. So if you look at the equation, we have Fe3 positive ions gaining electron, forming Fe2 positive ions, and the E naught value, which means the electrode potential value under standard conditions is positive 0.77, right? It's positive 0.77. So now if you see, if I increase the concentration of Fe3 positive, then what would happen to the equilibrium? Equilibrium shifts towards the right. And if equilibrium shifts towards the right, that at the end, when the equilibrium is reestablished, we have a greater Fe2 positive. And if we have a greater Fe2 positive, then it means this value would also increased. Okay. So we would just write that E of Fe3 positive, Fe2 positive increased. कर लें मगर इस तरह ज्यादा बेहतर है. Okay, now what would happen the other way? In the second part, they ask you if the Fe2 positive ion concentration decreased. So if it is decreased, sorry, if it is increased, what would happen? The equilibrium shift to the left. So we have a more of these and less of these when the equilibrium is established. So it means E naught value decreases. So no, E value. E naught means the standard conditions. We are talking about a non-standard condition. So E of Fe3 positive, Fe2 positive decreased on increasing concentration of Fe3 positive ions. Is this understandable? Yes, is this clear to everyone?
Yes, sir.
Okay. Now, I am going to make one equation over here, and afterwards, whenever if we will find any question like this, so you guys will make the equation and then WhatsApp me. Okay. So here, see, an aqueous solution of iron 3 chloride is used to dissolve excess of copper metal. So see, from this you are getting what information? It's iron 3 chloride, which is indicating that there is a 3 positive charge on iron. Is used to dissolve excess of copper metal, which means that initially it's copper in a solid state because it's a metal. From printed circuits, use the half equations and E naught values in the data booklet to write an equation for this reaction and calculate the E naught cell. Okay, so it means these two are going to react. So first, we will figure it out whether the reaction would occur or not, and for that, what were the conditions or what were the rules that we decided in the previous class? E naught cell. No, don't talk about E naught cell directly. What we have decided that yes, we will look into half equations. Okay, let me open the half equations over here. So if you see, we have a two half equations. That's what I'm going to tell you. Just wait a minute. First, understand this thing. There are two equations of iron 3 positive ions. Okay. And here, there is one more hint that you get over here, that it dissolves. That they are talking that in this reaction, the copper is going to be dissolved. So which means that copper is going to convert into copper aqueous. And if it is getting aqueous, so it can be any charge, whether a +1 or a +2. Okay. So for iron, we have these two equations. And if you see over here, for copper, it's an oxidation. Right? For copper, it's an oxidation. And if it's an oxidation, then in the case of iron, it must be reduction. Is this point is understandable? Yes. For the iron, it must be reduction. And the one which undergo reduction must have a greater E naught value. So see, we have these two values for iron. Now let's see where is copper. See, we have a Cu, copper metal in these two. So it means I can exclude this half equation of copper because in this we have both the ions. Okay. Now, if you look at these two values of copper, we can easily exclude this equation because as we decided earlier, the one which undergo reduction have a greater E naught value. Its E naught value is smaller, so I can exclude this one. So I'm left with this half equation. And here I have two options. So in this case, it doesn't matter whether I use this equation or whether I use this equation, because in both the equations, there is a copper metal and its E naught value is smaller than the E naught value of the one where the reduction is taking place. Is this understandable? But remember one thing, as we decided that here there is a reduction because our reactant is Fe3 positive ion, and here our reactants are these two which are undergoing oxidation. So for the equation which we choose that it is undergoing oxidation, we will flip that equation. Because, you know, if you see, if it's an oxidation, the backward reaction is taking place. So if I have to make the net equation, I have to show this reaction to be placed in the forward direction. So that's why I have to flip the equation for the reaction where the oxidation is taking place. Yes, is this understandable to everyone? So see, if anybody have still any doubt, kindly ask. What we will do, there is a Fe3 positive ions gaining an electron forming Fe2 positive ion, and its C naught value was 0.77 volt. Now look at the other equation. I'm going to take the 2 electron one because it have a greater difference, but it doesn't matter. I can take any one of those. Okay, but I have to flip the equation. So I'm flipping the equation. So I get a copper forming copper 2 positive ions plus 2 electrons, and its E naught is 0. 0.34 volt. If you get a experience of doing this, then you don't need to do all this working. I'm just doing this for you people. Otherwise, otherwise you can do it easily without this. Yes, you can do it directly because they haven't provided you a space. So the main task is to write the net equation over here only. So see here, how many electrons a copper atom is losing? Yes. So it means the 2 electron must be gained by the iron 3 positive. So we would multiply the half equation with the 2. And now I will add both the equations. So when I add both the equations, the electrons get cancelled. And we are left with the 2 moles of iron 3 positive ion reacting with the copper metal, forming 2 moles of iron 2 positive ion and forming copper 2 positive ion. So after cancelling out the electron, write the reactants on the left hand side of the arrow, write the product from the both the equations on the right hand side of the arrow, and your net equation is ready. Is this clear to everyone? Now E0 cell for the reaction, as we have decided that whenever we find the E0 cell, it is always reduction minus oxidation. So here reduction is taking place in the iron half cell, which is 0.77 volt, and then Chanan, would you tell me the answer? Oh, sorry. Both are negative. Sorry. Zero point 43 volt. Yes, is this understandable? Yes, the online one, Ahmad, Alishba, Hamna, Iza, Mariam, Moez, Rida, Saliha, Sania, Shiza, Talha. If anybody have any doubt, kindly ask. Otherwise, I'm now going to give you a question. Transition as well. Okay. So everybody is done with this thing? Okay. Here you have two cases. Now do it on your own, and if you find any difficulty, do ask. Now it's your, you will do it, and my net equation from this. Yeah. Okay. आप अपना करें जल्दी से, आप लोग प्लीज जल्दी से कीजिए, और अगर किसी को कोई क्वेरी आ रही है तो वो मुझसे पूछ लें. One minute.
Yes, take the help from the data booklet, use the half equations and do it and send them quickly.
हाँ अभी की एग्जांपल नहीं देखी तुमने? हाँ yes, as you finish it, share it with me. साइड करें कि यहाँ yes 2 plus, so it means वो इक्वेशन यूज होगी जिसमें आयरन 2 plus है. यहाँ पे Fe2 plus लिख, Fe3 plus वाली क्यों लिया? नहीं, हाँ ये ऑक्सीडेशन करेगा, ये रिडक्शन करेगा, तो ऑक्सीडेशन भी कौन करेगा? Fe में से कौन सा Fe2 plus, तो इसका मतलब ये Fe2 plus तो नहीं कर रहा ऑक्सीडेशन, तो उल्टी तो हम तो यहाँ से ले रहे हैं ना, तो यहाँ से वो इक्वेशन होनी चाहिए ना जिसमें Fe ऑलरेडी यहाँ पे, क्योंकि वो बैकवर्ड रिएक्ट कर रहा है. पॉइंट समझ में आया या नहीं आया? तो इसका मतलब ये हुआ कि only this is the equation. You have only two equations in Fe2 positive. In this equation, it is undergoing reduction. In this, it can undergo oxidation. तो ये equation use. हाँ, और वो ऑक्सीडाइज हो रहा है. ठीक है, ये बात क्लियर होगी। नाउ कम टू MnO4, इसको रिड्यूस होना है, सो we have 1 2 3 with MnO4। अब इन तीनों में से जिसकी वैल्यू इसकी जो हमने इक्वेशन चूज की है ज्यादा होगी वो यूज होगी, और अगर दो की है तो हम दोनों में से कोई भी एक यूज कर सकते हैं। आप कहाँ तक पहुंचे? ओके, जी कितनी कितनी कर ली है सबने? बोथ? सही लग रही है, सही लग रही है। कहने को तो क्या ट्रिक बताऊं, रिकॉर्डिंग्स देखना शुरू करो और शेयर द रिकॉर्डिंग्स। सही है। सही। एक काम करें, पहले दूसरे की भी हाफ इक्वेशंस चूज करके नोट कर लें यहाँ पे, फिर उसके बाद ये करिएगा। पेपर 5 की क्लासेस ले तो रहा हूँ, साथ साथ करते रहो, बाकी पेपर 4 के बाद कर लेना। Who left the class? Okay, just WhatsApp me. We're done with the equations. Do it quickly.
Yeah, sir, WhatsApp them.
Okay, I'm checking. कौन सी वाली? ये वाली। आता तो है। Now, what other equation you would use? It's chromate, right? So look for chromate. It's so here. क्यों कम है? तो 1.33 है. कौन सा clear है? हाँ ये वाली यस.
ये वाली आप दे दो. मुझे ये बताएं कि कैसे डिवाइड हुई है.
इसमें कोई डिवीजन नहीं है. ऑर्गेनिक में कितनी डिवीजन करोगे?
तो पहले सारा सिलेबस करो फिर स्टार्ट करो. कोई वो नहीं है.
Okay, let me check who sent me. Okay, Hamna. Good. Sanya. You didn't send.
Sir, I'm sending.
Okay. And nobody else sent yet. Why? Do it quickly. Yes, nobody else sent me yet. Okay. What about the rest of the students? Whether they are able to attempt it or not? Okay. So see, if you look, you have a one, help over here that they have told you that potassium magnate. Okay, 1 minute. What they have told you? That potassium magnate 7 and potassium dichromate 6 are both used as a oxidizing agent in acidic solution. So it means they both are if oxidizing agent. So it means they both undergo reduction. So it means we have choose the equation, the half equations for these two, where these two are undergoing reduction. So it means this would undergo reduction and this would undergo reduction. So it obviously suggesting me that this one undergo oxidation and this one also undergo oxidation. Is this is clear to everyone?
Yes, sir.
Yes. Okay. Now, so, okay, Sania, you have sent me, let me check. So if you look at over here, that iron have a 2 positive oxidation number. You didn't make the net equation, Sania. Okay. So here the oxidation number of the iron must be 2 positive. Is 2 positive? Okay. So if it is undergoing oxidation, then the thing that we discussed in the previous class, this, when I am referring to the data booklet, this iron 2 positive must be on the right hand side of the equation. Yes. Does everybody remember this point or not? So if you see over here, we have one Fe2 positive over here and one Fe2 positive over here. So I ignored this one because there is no Fe2 positive. I ignored this one as well because in this one iron, if there is iron 2 positive, but it would go reduction. But according to the data provided to me, that iron 2 positive would have go oxidation. So that's why I have choose this value. So, and as it is undergoing oxidation, so as what we discussed, that the one which undergoing which in which the under oxidation would happen, we would flip the equation, right? So I will write over here Fe2 positive arrow Fe3 positive plus electron. Is this clear? Yes, is this clear to everyone? Okay. Now let's move to the KMnO4. You wouldn't find KMnO4, but you would find MnO4 negative. See over here. And as we have already decided that it's an MnO4 negative which is undergoing reduction, so it clearly means that when I refer to the equation in the data booklet, this MnO4 negative must be on the left hand side of this equation. So here you go, these two. Okay, but the other important thing, that its value is positive 0.77 volt. So if it is on the left hand side of the equation and it is undergoing reduction, so its value must be greater than 0.77. So if you look in these two equations, in both the equations the value is greater, right? So we can use any one of out of these two equations. So let me use the first one. So the first one is MnO4 nons no 4H positive plus 3 electrons ये आपको इक्वेशन दी हुई है, मैंने ये वाली ले ली ऊपर वाली MnO2 plus 2H2O और इसकी E नॉट वैल्यू क्या है 1.67 है, सही है, ज्यादा ही है ना. Okay, so now I have chosen the equation. Now I have to make the net equation. So here it's 3. So what I do, I multiply the above equation with the 3. Okay. अच्छा, यहाँ पे आप एक और भी काम कर सकते हैं, आप दोनों तरीकों से समझें ताकि आपको बात समझ में. You may understand we are using both the ways. Okay. In the first case, Fe3 positive plus electron. If an student would have chosen the other equation which I didn't choose, which was MnO4 negative plus 7H positive plus 5 electron. Yes, 8H positive plus 5 electrons. MnO4 negative plus 8H positive plus 5 electrons. Mn2 positive. Okay. So this is the other case. In this case, I would multiply the equation with the 5 to balance the electrons. Now in both the equations, the electrons are balanced. So here the electrons are cancelled out. Here I get 3 moles of Fe2 positive. So you would write the species which are on the left side of both the arrows on the left and the one which are on the right side. So this is the net equation. In the same way, you can make there is the other net equation as well. You have to add it. So where it would you have CO? So it is 1 minute. Fe2 positive plus MnO4 negative plus 8H positive. I'm making the product in this way. Sorry, plus 4H2O and Mn2 positive. So these are the equations. Is this understandable? If anybody have any doubt or any confusion, kindly ask. Okay, Mariam, you have sent me. Let me see. Okay. In the next case, we have a chromate and SO2. Okay. So as we know that SO2 must be oxidized, right? So if SO2 is oxidized, so it must be on the left hand side of the data booklet on the equation. So it would be this equation only, where its potential is positive 0.17. So when I write this equation, I flip the equation. So here it would be SO2 plus 2H2O forming SO4 2 negative plus 4H positive plus 2 electron. 0.17. Okay. Now it is reacting with the chromate which have a 2 negative charge, and there must be two conditions. Its value must be bigger and it must be on the left hand side of the equation. So its value is positive 1.33, which is greater than 0.177. So dichromate ions, 14H positive, 6 electrons. Here we would be getting 2 chromium 3 positive ion plus 7H2O. Okay, now you have to balance the electrons. So it would be very easy because I have to balance the electron. To balance the electron, I have to multiply the above equation with the 2. So 2, 6, sorry. Yeah, 3, sorry. So 3, 6, 3 sulfate. Here it would be 12 hydrogen ions and 6 electrons. Now I would add this. So the net equation would be 3SO2 plus Cr2O7 2 negative. Okay. Here if you see on both the equations, we have a hydrogen ions on the opposite side as well, right? So these 12 would be cancelled out and we are left with the 12 hydrogen ions. 12 hydrogen ions are left behind. Okay. No, 2 hydrogen ions. Sorry. So we are left with the 2 H positive ions and then 3 sulfate ions, 2 chromium ions, and 7 H2O. Yeah, 6 H2O would be cancelled out from here and we are left with 1 H2O. Now is this clear to everyone? Please अगर किसी को कोई confusion है तो पूछ लें. Who else is joining? Okay, Ahmed K is here. Okay. Now another thing, when we talk about KMNO4 is often used in titrations to estimate the reducing agent. It is added to from a burette to a solution of the reducing agent. Okay, am I audible to everyone? Okay. Now, yes. What is the color change? What is the color? It's purple. The net went again. बाहर वाली नहीं कहती. What is the end point? Yes. क्या? This is the pale pink or pale purple. Okay. The difference is this here that you need to understand when we use acidified potassium permanganate, as a reagent and we are just mixing in another container, then it just goes and it decolorizes. That is for the identification of a something. But when we are doing titration, in titration, KMnO4 potassium magnate is always, filled in the burette. Okay, it is always filled in the burette, and we very, uh, carefully adding that KMnO4 into the flask and shaking. So every time when I add few drops of the KMnO4 into the flask and shake, it always goes decolorized. So that decolorization is taking place at every moment. So how could you say that it's an endpoint? So at the moment when all the reactant in the flask is actually consumed, and after that when you add the next drop, and that next drop does not react, so the color doesn't change. Instead, it is spread in the whole container, giving you the pale pink or a pale purple color. Is this understandable to everyone? So this is the difference while writing the color change. If they are talking about the color change during the titration, so it is from purple to pale pink or pale purple.
During the titration or the end point?
During the titration, at the end point, you will get this when you are doing the titration. But when you are just adding the KMnO4 in any test tube to identify a specific substance, for that you just write the observation purple to colorless. Is this clear? Okay. I'm just going to select any random question. Okay. Let's start with this question. I want you guys to answer this. Okay. That's a definition. So I'm just leaving the definition. You have to just memorize the definition, or you have to be clear the concept, and then you can write the definition very easily. Okay.
Definition.
These are in the notes. You can find them in the notes. Okay. Okay. Now here, the following incomplete diagram shows the apparatus that can be used to measure the E0 cell for the cell composed of Fe3 positive, Fe2 positive, and Ag positive, Ag half cells. Okay. Complete the diagram, labeling the components you added. Okay. So, क्या डलेगा भाई? What we can add in it? How could we complete the diagram?
अच्छा diagram से वो डाल दे voltmeter
Voltmeter
voltage
and salt bridge. सही है? Okay, now identify the components A to D.
the E is platinum
Why?
because the item solution तो ions
दोनों
ions भी
A सिल्वर नहीं हो सकता?
E silver
The incomplete diagram shows. Okay, I'll tell you one more thing. See, first look at their values. I think this value everybody can easily recall. It's 0.77 volt.
Yes, sir.
Right? And here is the data. Here is the silver. It's 0.80. Okay, so in this case, it could be anything. It depends. Okay, but when we talk about this half cell, in this half cell, the electrode is of platinum, and in this half cell, the electrode is of silver. Is this understandable to everyone?
Yes, sir.
So it means if I am taking A, let's suppose, if I am taking A as a silver, then B would be the electrolyte of a silver, and the most soluble electrolyte is a nitrate of any salt, so it would be silver nitrate. Is this understandable? Or the otherwise I can write platinum as A, and then B have a Fe3 positive and Fe2 positive ions.
Sir, one more per decimeter cube. Listen to me.
No, here they are just asking you to label. So in C, what is C? Okay, so C is platinum, and then we have a Fe2 positive aqueous and Fe3 positive aqueous.
So मुझे ये वाली बात समझिए.
What?
Silver electrode.
What? What you don't understand?
दोनों platinum के use.
Because here there is no silver ion. It's a silver metal. So if it's a metal, then that metal must be an electrode. If you see here, both are ions. So that's why it's a platinum electrode is used over here. Yes, is this clear to everyone? Now what they are saying? Use E naught values to write an equation for the cell reaction that takes place if the two electrodes are connected by a wire and the circuit is completed. Yes, I think now it's easier to write.
0.8
Yes, it's 0.8 and it's 0.77. Now, in this case, if you see, if you compare this case with the previous cases that we did, in the previous cases, there is not a half cell like this, where we have to write the equation. So we have to decide the species very carefully. But in this case, we have both the species from each half equation. So we will just see the values and then we can easily figure it out which one is undergoing reduction and which one is undergoing oxidation. Even afterwards, you don't need to write the see the data booklet as well. Yes, silver would go undergo reduction and iron would undergo oxidation. So now, see, I can make the equation now. It is, I would have reduce. So it means there must be a silver ion. be a iron 2 positive. Wait. Okay. So then iron 2 positive would oxidize to give you iron 3 positive, and Ag positive gains electron to give you Ag. So that would be the net equation. Is this clear? And if you have any difficulty, so you can take the half equations. You have a half equation for iron. Ag would be Ag positive gaining electron, forming Ag metal. And as we decided that iron half equation would do oxidation, so it would be flipped. So if you flip the equation, it would be like this: Fe2 positive forming Fe3 positive plus electron. So you add them, cancel the electron. So see, now after adding, you will be getting this equation. Okay, now see over here. This is the next thing that normally we call it nest equation in this part. A nest equation, we uses this equation when we have a non-standard conditions in electrochemical cell. So another electrochemical cell. Assalamualaikum. भाई मैं क्लास ले रहा हूँ. Another electrochemical cell was set up using 0.31 mole per dm cube silver ions instead of the standard silver solution. Okay. Now it means we don't have a 0.1 mole per dm cube, but we have a 0.31 mole per dm cube silver ion. Use the Nernst equation. E is equals to E naught 0.059 log constant values to calculate the new E cell in this experiment. So see, they have provided you the equation, the expression, and you have to use this expression to find out the E value of the silver half cell and then E cell. Okay, E cell is always measured when we subtract the one oxidizes its E value with the one which reduces. So first I will find the E, that E means non-standard conditions. The value under non-standard conditions is equals to E naught. E naught for the silver was 0.80 plus 0.09 log concentration of silver ions, which is
7
so
769
0.770 volt. So this is the new E naught model, which it's a formula. See, yes, it's a formula over here. Look, that's why we have added E naught 0.80 plus 0.0591. बट अब आपको इन 10 notes में जरा देख लीजिएगा. You have to memorize as well this expression. So we got the 0.770 volt. Okay. Now, what would be the E cell now?
E cell.
0, because if you recall, iron half cell also have a 0.77 volt. So both have a same value. So the new E cell would be 0.77 minus 0.77. So we got 0. Yeah. Is this clear to everyone else? If anyone have any doubt, kindly ask. Now, an electrochemical cell was set up to measure the standard electrode potential E naught cell of a cell made of cobalt, 2 positive cobalt half cell and Fe3 positive, Fe2 positive half cell. So from here I can easily conclude that here the electrode is of cobalt and here the electrode is of platinum. Complete the substance used to make the electrode in each of these half cells. Okay. So cobalt and platinum. Is it clear?
Yes.
Overall cell reaction. Okay. So it's very easy. If you recall, we easily remember that it's a 0.77 volt. The iron 3 and iron 2 positive. Now I have to look. Yes. But I have to figure it out first. This cobalt and cobalt 2 positive ion and it's minus 0.28. Right? So it can be easily identifiable. Here oxidation would occur, and here in oxidation this species would be converting into this one. And here there is a transfer of one electron because plus 3 to plus 2, and here plus 2, which means transfer of what I would do, I would make a 2 coefficient over here. So see, so the net equation would be Fe3 positive, first, second cobalt, then arrow, third 2 moles of Fe2 positive, and fourth CO2 positive. Is this clear? Now they are asking you to calculate the E naught cell. So E naught cell would be calculated easily by 0.77 minus 0.28. 28. It's 0.99, I suppose. No.
1.05.
1.05. See, again we have a Nernst equation. The electrochemical cell 0.05 mole per d. So now it's not a standard. So if I have to figure out the value of its E value, then I have to use the Nernst equation. The Nernst equation can be used to calculate the value of an electrode potential at a different concentrations. Use the data booklet and the Nernst equation to calculate the value of E for the CO2 positive cell in this experiment. Okay, E naught is minus 1.28. Minus 0.28. Okay, so it is minus 0.28. Now, if you look at its half equation, let me show you.
Divided by 2.
Yes, how many electrons are involved? 2 electrons are involved. So these electrons are basically Z. These electrons are basically are the Z 0.059 over 2. Then log on CO that is 0.050. So this Z is actually number of electrons. Resolve करें. Kindly do it and tell me the answer. Minus 0.32 volts. Is this clear? Now, see the other thing. Suggest how this change will affect the overall cell potential compared to E cell in D3. Circle your answer. D3, we have this value 1.05 volt.
Yes, sir.
Now, the new half cell potential is minus 0.32. So if I put this minus 0.32 over here, my value will be increased. So I would say more positive over here. Is this clear? Any confusion?
No, sir.
Okay, then we will keeping our class till here. Further discussion in the next class. Okay, take care, everyone. Thursday. वो मैं morning में उसी दिन बताऊंगा. Okay, take care, everyone.